To factor a difference of two squares, a sum of two cubes, and a difference of two cubes. A set of flashcards. For the following slides, you have the following options, and all you have to do is say it out loud. It's either going to be a difference of two squares, a difference of two cubes, a sum of two cubes, factorable, or not factorable. On this first one, what is this? Right, it's a difference of two squares, and there's how it breaks up. What's this one?
Difference of two squares.
It is simply factorable by taking out a 3. And when you do that, you're left with x squared, but 2 is not a perfect square. What's this one? Yeah, this one is a cube and this one is a square. So it's not factorable. What's this one?
Factorable. Difference of two squares. Sum of two squares. Sum of two squares. Not factorable.
Not factorable. Because we don't have a sum of two squares. What's this one?
Sum of two cubes. Factorable.
Yeah, this is a cube, so is this one and this one. So it's the sum of two cubes, but I wrote difference for some strange reason, so I'll go back and fix this. And it's not, yeah, it is supposed to be cubes, that's right, but it's supposed to be the sum of two cubes. What's this one?
Not factorable. No, it's factorable.
It is factorable.
Yeah, it's factorable.
It's factorable, and what else?
Difference of two cubes.
Yes, once you take out a 5, you're left with x to the third and then minus 8. So that gives you a difference of two cubes. So keep the 5 and then do this one as normal. What would this one be? Not factorable. What's this one? What can I take out of it? 2. What's this one?
It's the difference of two cubes. Yeah, because you can, when you take the 12 out of it, it becomes 32. Oh wait, no.
You can take a 12 out, but you're left with x cubed, but the 3 is not a perfect cube. If you're ever in doubt about whether it's a cube or not, for instance 3, and then the caret symbol, parenthesis, 1/3, and it'll come back to be a decimal. That tells you it's not a perfect cube. What about this one? Yeah, difference of two cubes. What's this one? Nine? What's 9? Is it a cube or a square?
Square.
What about x to the 4th?
Square.
It's a square. What about 25?
Square.
What about y to the 6th?
Square.
It's a square. What's the square root of y to the 6th?
Y to the third.
Y to the 3rd. So it's a difference of two squares. What about this one?
Difference of two squares.
Yes, it's a difference of two squares. And this is what it is when you first break it apart. But notice that the back end by itself is a difference of two squares. So if you ever see that, you continue it on with that and do 2x squared plus 1, 2x squared minus 1. You're breaking this one up too. So always go as far as you can when necessary. So this one has 3 quantities when you finish with it. What is this one? Yeah, 64 is a cube. So is x to the 9th, 125, and x to the 6th. What's the cube root of x to the 6th?
X to the third. No, X to the second.
X to the 2nd. If you ever want to figure out if the variable is a perfect cube, then divide the exponent by 3. If you divide it by 3 and it comes out to be an integer like 2, then it's a perfect cube. If I divide 9 by 3, then I end up with 3. So x cubed, and then that should be a y on the back end. Y squared is what it should be, but I wrote 2 x's in there. But you can still do it. And it is the difference of 2 cubes. Notice in this one, for some strange reason, I put an x there, and then everything else was right, except for this. But it's still the same idea. Just a typo on my part. What is this one? It's simply factorable because all you can take out from both of them is a 3. What if that plus sign changes to a minus sign? It is factorable. It's got to be a difference. Difference of 2 what? When you factor out a 3, you're left with 4x squared minus 9. That is a difference of 2 squares. A difference of 2 squares. So leave the 3 and then find the square root of this. And actually, there's another mistake. That should be 3. There. 2x plus 3, 2x minus 3. What about this one? Is 3 a perfect square? Not factorable. What about this one? It is not a difference. It's a sum of 2 cubes. Yeah, this one should be the sum of 2 cubes. I made a bunch of mistakes on this one this time. At least we fixed them. And what is this one?
Difference between 2 squares, or sum of 2 squares.
Not factorable. There is no sum of 2 squares. What's this one?
The sum of 2 cubes.
Sum of 2 cubes. What is this one?
Sum of 2 squares. I mean, a difference of 2 squares.
It is a difference of 2 squares, and when you go to work it out, this is what you get from the beginning, but notice that the back end is also a difference of 2 squares, so you break that one up as well. What's this one? Remember the way to figure out if it's a perfect cube or not is to divide the exponents by 3. Does it work in this case? No. Yeah, if it's a perfect square, you divide it by 2, and in this case you would get x to the third and then y to the second. So yes, a difference of 2 squares. Alright, here's a practice. Bring this one up, but don't just write down what it is. You have to work it all the way out. For the practice problem here, this is a sum of 2 cubes. So the cube roots are x and 2. Since it's a sum, that means you have minus plus in the back end. Square this one, multiply them together, square that one. The solution here for the practice. If you divide this power of 6 by 3, you end up with a 2. So a cube root could be x squared. But if you divide it by 2, you get x to the third. That could be a square root as well. The key to this is the 125. If you put 125 into your calculator, caret, and then parentheses around 1/3, you'll get back a 5. That means it's a cube root. A square root will get you a decimal. So the cube root of x to the 6th is x squared. And then minus 5. Then on this side you must have plus and plus. Square this one, multiply them together, and then square. 25 is the perfect square, so is x squared and 1. The square root of 25 is 5, square root of x squared is x, and the square root of 1 is 1. You must alternate the signs.